Today we're going to be graphing parallel and perpendicular lines. Parallel lines are lines that have the same slope. Perpendicular lines have a slope that is opposite and reciprocal. Opposite, of course, means negative. So if it's a positive slope, it's going to be a negative slope. If it's a negative slope, it's going to be negative, negative, which is a positive. And reciprocal means that if it's a slope of 1/2, it's going to be 2. That is, you flip the fraction upside down. So that'd be 2/1, which is 2. But again, I said it was opposite. So if it's positive 1/2, it will be negative 2. Now let's look at a couple of graphs to demonstrate that. On the first graph, we have two parallel lines. Let's see if they have the same slope. Well, the light blue line has a y-intercept of 7. So let's go down 3, that would be in a negative direction, and run 2, that would be in a positive direction. So our slope there would be -3/2. Let's look at the slope for the dark blue line. We have a y-intercept of 1. So from that point, let's go down 3 in a negative direction and run 2. That would be -3/2, so you can see that they have the same slope. Parallel lines will always have the same slope. Now let's look at perpendicular lines. On this dark blue line, we have an x-intercept of 4. Do you see that? It crosses the x line at 4. And if we rise 2 in a positive direction and run 1 in a positive direction, we have a slope of +2, or 2/1. Now let's look at the pink line. The pink line has a y-intercept of 4. So from that point, let's go down 1, that's a negative direction, and run 2 in a positive direction. That would be -1/2, or -1/2. Well, the blue line has a slope of 2, or 2/1, and the pink line has a slope of -1/2. So there you see, it's reciprocal and opposite. It's reciprocal and negative. So based on that information, let's work on some problems. Find the slope of a line parallel to 5y minus 2x equals 7. Okay, we know that y equals mx plus b, which means we need to isolate our y. Let's get our x over on the other side. Let's bring all that down. And as you probably know, that 2x should be in front of the 7. But we're just trying to find the slope, and so the 7 is not important to this, so we're just going to leave everything alone. But we still need to isolate that y. And that will do it. 5/5 is 1. So there we go. We've isolated our y. And we know that 1y equals mx plus b. So when we have our y alone, the coefficient in front of x is our slope. So our slope is 2/5, and that is the answer to this question. The slope of this and any lines parallel to it are going to be 2/5, 2/5. So let's try a problem with perpendicular lines. Find the slope of a line perpendicular to 3x minus 4y equals 2. So we solve this in the same manner. That is, we need to isolate our y, so let's get x on the other side. Let's bring all that down. And just like parallel lines, the only thing we're concerned with is slope, so the unit value has nothing to do with anything, so we're going to leave that right there. And let's isolate our y by dividing everything by -4. -4/-4 isolates that y. And our coefficient in front of x is -3/-4. Can't have -3/-4. A negative over a negative is a positive. I think we learned that in our first lesson. So our slope is 3/4, and our perpendicular slope is going to equal -4/3. Now that upside down t I have next to the m, the second m, is the sign for perpendicular lines. And so the perpendicular slope is going to be our fraction here, upside down, and this is positive, this will be negative. And that's how you find the perpendicular slope. Now let's do another problem. Find the equation of a line through 4, negative 5 in parallel to 2x minus 3y equals 6. Now we already know how to find the slope for parallel lines. We're going to find the slope for this line here, and the line that we're going to need is parallel, so it's going to be the same slope, but it's going to have to pass through this point here. So we're going to have to build an equation that does both of those things. There you go, that'll move the x, so let's bring all that down. And let's divide that y and everything else by negative 3. That will isolate our y. And our x has a coefficient of negative 2 over negative 3, so let's make negative over negative, positive over positive. So our slope is 2 over 3. So let's erase all that work and bring out our point slope formula. And let's start plugging in some values. Now y we leave alone. y1 we get from the point, and that would be negative 5. And negative 5, we can take care of that later. We can take care of it now. Why don't we take care of it now? Our m value we've already figured out. That's what all those calculations were about, and we came up with a positive 2/3. X, of course, we're going to leave alone. x1 equals 4. Let's distribute that 2/3. Let's bring that 5 over and bring all that down. And if you don't know how to add negative 8/3 plus negative 5 to get negative 23/3, then you need to go back to the pre-algebra lesson on fractions and how to add them. But this is our solution. Y equals 2/3 x minus 23/3. That is the line that satisfies the parameters of the question, which is to get the slope right, and the slope has to pass through this point here. So let's try the same type of a problem with perpendicular lines. Find the equation of the line through 6, negative 9 perpendicular to y equals negative 3/5 x plus 4. Well, they made life pretty simple for us because we didn't need to get x on the other side. It already is. And we don't need to get y alone. It already is. So we have 1y equals negative 3/5 x. And so the coefficient in front of x is going to be our slope. Let's put that down. Our slope is negative 3/5, but that's not what they asked us for. They asked us for the perpendicular slope. So we're going to take the slope that we have and flip it upside down. And that looks good. Our perpendicular slope is negative 5/3. That looks pretty good, don't you think? That's right. Not only do we need to flip it, it needs to be the opposite sign. So it was negative 3/5, and it's going to be positive 5/3. And that is going to be the slope for our perpendicular line. Now, why don't we solve this the way we did last time with the slope-intercept method? That's right, y equals mx plus b. The value for y is negative 9. The slope that we agreed on is positive 5/3. The value for x is 6. Let's multiply that out. And that gives us 10, but let's isolate b and bring that down. And the value for b is going to be negative 19. Let's put the slope-intercept formula in again. And this time we're going to leave y alone, but we need to put the slope in. So m equals 5/3, 5/3 x, and the value for b was negative 19. And there you go, y equals 5/3 x minus 19. That is the equation of the perpendicular line that went through that other line and also went through this point up here. Now let's try something a little special. Find the equation of the line that passes through 3, 4, perpendicular to x equals -2. Well, we've already told you that when y equals, without an x value, that is a zero slope situation, and when we have x equals something like this, x equals -2, we have a no slope situation, and so we can't use perpendicular equations to solve this. And this is the way we solve this. It does not matter what x equals. That x can equal -2, +8, it doesn't matter. The answer to this question is the value for y. Since the point we are given has a value of 4 for y, that's going to be our equation. Y equals 4. That's all we have to do. And it is something extra that you have to remember, but the work is extremely simple, as you can see. Now let's see what happens with x. Find the equation of the line through 3, 4, perpendicular to y equals 3. And this is just the reverse of what we just did. And instead of an x formula, we have a y formula. Y equals, and again, it doesn't matter what y equals. If y equals something, then our perpendicular line is going to be the x value. That's right, since our point has a value of x equals 3, our formula is going to be x equals 3. And that is it. Don't forget to do your homework.